So first let me confirm that this part is clear, that if there is no curly braces or no scoping, only the first statement is under the if block. Okay, the recording started now. So I'll just repeat what I said. So if there are no curly braces or the scope, the first statement is assumed to be under the if clause, and all the rest statements are assumed to be outside the if clause. So not assumed, the compiler's direction is like that. Okay, so I think that goes inside the recording. So anyone who sees the recording understand why I did that. Okay, so now deleting this part and coming to our actual problem. Okay, I'll just make this problem a bit more harder by removing this a equals to c. Now what happens is this if condition is directly under this if. So this is the first statement. So this will get executed. Previously, if we did a equals to 6, then only a equals to 6 would have been executed, and rest of the statements were considered outside of a. So they wouldn't have been executed. So now the question is that if I execute this, this will else will be executed for what if this satisfies, I mean if this if does not satisfy, will this else get executed, or if this if does not satisfy, will this else get executed? So previous day I said about this that else go with something if you can remember you answer, or if you don't then I'll just tell you. Okay, so if you remember, can you answer? I did not share the notes because it was not complete. So after we do switch cases and day 4 is complete, so I'll share that. Okay. So, any answers, any ideas, anything? See, I try to make the class interactive, so you can't tell me that I'm going fast just trying to complete. Okay, the question is, if we run this, then this if will get satisfied or not satisfied. That's the thing. So, and this else will get executed if either this if not gets executed, I mean not satisfies, I mean this a less than equals to 6 is not satisfied, then this else might execute, or if this if does not execute, then it also might execute. So but it cannot like happen for both the ifs, right? There is something for which the else can only execute when one of the ifs does not satisfy. I just want you to ask uh, which if do you think? So it's like a bit tough to put it into words like what I'm trying to say, but the question is like this will else will execute if this does not satisfy or this does not satisfy, I mean the second if. So the first or second, uh, if you have any answer. Sanjukta says if a less than equals to true, not true, then else will work. Okay, so uh, she says like the first tip. Okay, anyone has any other answers? A less than equals to, okay, everybody is with first tip, and that's not at all surprising because you guys are coming from Python. So but the answer is the second if. Okay, because I said else always uh, looks at the previous only if. So if I showed you this, see, okay, no, this is else if. Why did I write? Yeah, else statement. If the condition within the if statement is evaluated as false, then the control jumps to the scope of the else, okay, and executes the operations. So did I not write that else only goes to, okay, I did not write this, but I said this. Okay, so else always looks for the last if, okay, not what if condition happened two times back. So the indentation might make you think that this else if is I mean attached with this else, but it's not. This else will only execute when this if does not. So in this case this is 5, so this if executes the inside if will now run because this is the only statement inside this first statement. So this is under this if. So this if will run and this will be false, and then C out should be printed. So see, okay, that did not work. Okay, wait a second. Uh, for some reason this if is not executing. Okay, just a second. I might be now into a bit of embarrassment, you know. So I'll just see that if this if is executing or not. Okay, yeah, this if is absolutely executing because a is less than 6, right? So this is executing, that's why this else is not executing. So I'll just give it a greater than 5, and now you see that this if does not execute and this else is going to execute. Okay, unqualified ID before else. Okay, might be VS Code is something in which dangling if else does not work. Maybe that's the case. I don't know. I mean, different compilers work different way. Okay, remove this. Yeah, now it works. So VS Code is a bit sensitive with this thing. Okay, no, that's not the problem. It will work with this. VS Code is actually sensitive with this if curly braces. Okay, so I'll just explain. You guys might be now confused. So see, this is 5. This if gets executed, the only the first statement under this is if. So now it tries to evaluate this if, which is greater than, which is if a is greater than 5, make it 7, but a is not greater than 5, it's equals to 5. So it does not execute. That's why this if executes. Now, if I'll show you the reverse, that is what Sanjukta and Monal said, that if the first if is not executed, then this should execute. So the first if condition is a less than equals to 5, so we'll just give it 6 and we'll see. See, nothing is printed. That means that this if does not execute, and it does not go inside this, so no chance of checking if this if is true or not, and no chance of checking this else as well. So it just goes to the end of the program and it finishes. So this is the dangling if else problem, and this is actually not a problem. It works with the compiler directions only, but this is what happens when you don't give proper indentations and write messed up code, don't give curly braces, and so the person who is reading your program gets all jumbled up. Like you must have also have, I mean, you must have also thought why are we doing this? But this is a problem when what happens when you do wrong indentations. Okay, so if and don't give curly braces. So the equivalent code of this is like this. I'll go into questions. Just give me a bit of time. And this code, this all messed up code, is equivalent to the one I've written here. So now questions. I know you must have a question. If you're not having a question, then probably you're not following the class, or you're too good at understanding this. One or the other might be true. Is just like the if statement. So if you understand, probably you're too good. If you're too good, then that's all right. Else you should ask a question. Okay. Okay. Yes, here you did not understand. That's fine. Okay. Did Munal, did you understand that else only follows, I mean, only looks after to the previous if, looks for the previous if. If that satisfies, then it does not run. If that does not satisfy, it runs. Did you understand this part? Okay, that's fine. So like if we have a lot of ifs like this, uh, if, if, and else, this I showed last day, and a lot of else with that hi, good evening type of example, then this else will only execute if the previous if does not satisfy. So you understand that part, fine. No issues with that. Now see, and I said like if there are no curly braces in a if statement, these curly braces are not there. So the only thing that gets executed if the if satisfies is the first statement. So let's just say statement 1. So if this if satisfies, then only the statement 1 will be executed. All other statements would be like outside the if, so they don't depend on the if is satisfied or not. They will execute irrespective of the fact the condition is true or not. So you understood that part as well. So I think that will like you just have to just see the syntax here. That's all. So I think you just need a repetition of the explanation. So see, uh, if a less than equals to 5, this is the first checking, right? So we are checking a less than equals to 5 or not. We'll just give the previous value. So this is true. So we get into the our if clause. Now we are inside our if clause. So we are checking the first statement will be executed because there are no parentheses. So if a greater than 5, we'll do 7. And dangling if else says that, I mean the if else property says that the else looks at the previous if that is satisfied it will not execute, if that is not satisfied it will execute. So this if not satisfies because a is equals to 5, but our condition is a greater than 5. So this is not satisfied, so else looks that my previous if did not work, so now I have to work. So it prints the value of 5. Again a problem with VS Code. Why is VS Code so sensitive? Like it does not run the same thing that I run last time. Okay, see just VS Code is very sensitive with this, but things code blocks like works with all this. It's not a problem with that. Okay, so anything you just have to modify yourself with the ID. Okay, Monal, now did you understand? Or because of this VS Code errors, you are still confused? So I'll just brief it up once more. That this if condition is first checked because there is nothing else before that, and it checks that a is less than equals to 5 or not. If a is less than equals to 5, it gets into the if clause. Because there are no curly braces, only the first statement comes under this block. So if this is if this satisfies, the else part will not satisfy because else only looks at the previous if condition and not the if conditions before that. So if this is not satisfied, then only this will execute, and if this is satisfied, then this will not execute. And also that if this is also not satisfied, like a is something that I showed, like a is 6, so this is not satisfied, and you thought like because of the indentation in you guys are for Python, you thought this will get executed, but it's not. Else only looks at the previous if. So that's how it works. I think I'm clear now, I hope. So anyone has any questions? That was a last if else thing. It's called a dangling if else problem, and this is only for languages that don't have indentation. So this won't occur in Python. If you do this statement, it will go with the first if. So that's why your answers were like L is then equals to 5. But I thought Sanjukta would give me the right answer because she learned Java. So Java also had the dangling if else problem, and it was also like taught in our classes. Anyways, so that's out of the way now. So we'll go into switch cases. So a switch case syntax, as I said, that this is a switch case syntax, and I did not write the definition, of course. So I'll just add this with the if else part, okay, so that you guys can remember this. That else else only executes if the previous if statement evaluates to false and does not. So this is actually very easy to understand, but the dangling if else problem is with that indentation thing, and that's all, nothing else. So we'll go into switch cases. So those who like attended the last class, I said that uh, the switch case in the programming is very similar to our switches only, but instead of having two states, it can have a lot of states. So our switches only have on and off, but in switch cases, you can like give the number of cases you want. So how does this exactly work? I'll show you. Okay. So this is a sample switch case execution. So we are assigning our a value, and now switch evaluates a statement. Okay, inside this it evaluates a statement just like if does, else does, else if does, sorry, not if, not else, I mean if does, else if does. So this also evaluates a statement, and gets its value. Okay, so this evaluated statement A, and there is no plus, minus, anything else. So it evaluates A, gets its value. So A's value is 6. So switch knows now A's value is 6. Now it looks into all the cases that are inside it. So switch, the scope of switch is given by these curly braces, as I said. This curly braces means scope, and under the scope there are a number of cases. Each case has its own value. So case one does not mean this is the first case. I can write this as case 5 as well. So case 1 does not mean it's the first case. Case 1 means that when the value of A is 1, this part will get executed. And case 2 means when the value of A is 2, this part will get executed. Case 6 means when the value of A is 6, this part will get executed. And this break statements are, so if case 1 is executed and then you break, that means we cannot go to, we don't fall through to case 2. Okay, so I'll come into fall through later, but right now, like, you just assume the breaks are there for, like, you have to give the breaks. Why breaks? I'll come into that in a bit. So basic first, we have to clear the basics. So case 1 executes when the value evaluated by switch case, which in this case is A, which is equals to 6. uh, Case 1 executes only when A is equals to 1, and case 2 executes when A is equals to 2, and case 6 executes when A's value is 6. So can you tell me, like, if I run this, what would be the value? I will come into default and break, don't worry about that. But right now, can you say, like, if I run this code, what would be the value that we'll be getting, or what will be the output exactly? Anyone? Anything? This is nothing. Okay. This is 6. Okay. Anyone else? Case 6 will be executed. This is 6. Fine. Yeah, you're right. This is 6 will be executed because, as I said, A's value is 6. So case 1 executes only when the evaluated expression's value is equals to 1. How? I'm explaining that on. Just wait. Do you know how default works? So this will be the default case. What you said is for the default case. A's value was 6. Did you see this part wrong? A's value was 6. Okay, initially. I initialized A with 6. So switch evaluates the value of A. So switch gets it as 6. Case 1 executes only when the value of A, the evaluated expression, which in this case is A, and which equals to 6. So if A's value is 6, sorry, if A's value is 6, then case 1 will execute. If A's value is 2, then case 2 will execute. If A's value is 6, then case 6 will execute. So A's value is 6, case 6 executes. That is, this is 6. Now you have any questions? I'll answer that if you have. I mean, how is, like, explained like that? And if you have any questions regarding the explanation of how, then I'll say that. Okay, yes, I was wrong. Okay, okay. Okay, so what Roham said is, like, the default case will execute. Okay, so when will the default case actually occur? That is the question now. So the default case occurs when A, all the cases are checked. So case 1 is checked, case 2 is checked, case 6 is checked, and none of it is satisfied. Okay, I mean, all the case values that are given, none of it, it is satisfied by the given value of A or whatever the expression is, then default executes. Okay, so if I give 7, there is no case 7. So it will execute default, and in that case, okay, again an error. Why does VS Code give this type of errors? I don't know. See, exactly the same code I'm running, and this is nothing, and this is an error. What? Really? That's why I don't think VS Code is a good compiler for C++ or C, but you know, that's the, like, popular one. But you just saw, like, I did the exact same thing. So just imagine you're running a big long code, and all of a sudden you get an error, and then you run it again and you don't get an error. You'd be confused what is happening. Okay, even I'm surprised. I have never seen something like this. Previously, I saw that when you select something and run the code, it gives an error. But this time, nothing was also selected and still it gave an error. And then it ran. Wow, nice job. VS Code almost gave me an anxiety attack. Okay, so this is nothing happens. So, I mean, VS Code is making me question my C++ knowledge or whatever I've learned. So A is 7. It evaluates A, which is 7, but it does not find any case satisfying that value. So there is no case 7. So it goes into the default part. Okay. So is this clear? I mean, till this is this clear? Or you have any questions? How default? Why one? Why this? And all that. Break, I have not explained yet. In case of two consecutive integer. What do you mean by two consecutive? Like the same consecutive integer, like case one and case one. Probably should be an error. Do you mean this? Int equals to 7 comma 1. 7 comma 1. Okay, we did not go into, I mean, this type of initialization you want. So this is an error. Like, I mean, how can you initialize 7 and 1? Okay, this does work. But if you want this, I mean, what do you exactly want? Do you want me to initialize it like this, or do you want me to give an case one after case one and want me to initialize with something, or do anything here? So that will be an error because two cases cannot be the same. See, case level value has already appeared in the switch at line 12. So that is an error. Okay, the first one. Okay, in case of 7 and 1. Okay, so we'll see what happens. So this is one. It takes, this is the comma operator. So I did not go into the comma operator, and I won't go into the comma operator right now because you don't need the comma operator. And I also forgot how the comma operator works actually. So leave that for now. And you don't need comma operator actually. You would find any program where the comma operator is used, to be honest. No programs I've seen where the comma operator is used. It's a very vague type of operator, and I also don't. I forgot how it worked. We had it in our syllabus, but I don't remember right now. So I can see and tell you that in the next class if you want. No issues. See, I accept that I don't remember that. Okay, so that's not part of the switch case also. So let's just get back into switch cases. Okay, so switch case, this value is evaluated and it checks the case. If the case is found, then it executes the statements corresponding to that case. And if case is not found, then it goes to the default. So now a question might rise that what happens if there is no default case? Can anyone answer that? So what would happen? Would it give an error like it does not find a default case, something like that error, or simply nothing would happen, just the switch case will end and the program will end? No output. Yeah, right. So we don't get any output, but this is absolutely valid. A default is given so that you can identify what is happening with the program. Okay, yeah, right, fine. That's out of the way now. Uh, Now what will happen is, what happens if we don't give a break? So first we'll execute this and see nothing happens because it is given 7. Go to 1 and see. Now you will be surprised what is happening. So we have given int a equals to 1, and we have got this is 1, this is 1 twice. Yeah, both cases. I mean, not even both. If I remove this break also, then that will be executed as well. So 3, this is a, this is a, this is a. And if, let's not, like for even more testing, yeah, then it's 3. Even more testing, we can like give this is 6. So we can understand that these 3 are only getting executed and not, uh, see, this is 6, no endl, so you get an like all jumbled up together. So I'm doing all this for just showing purposes. Okay, you don't have to do this. So this is 6, this is 6, and we had an a endl, so this is showing again. Okay, a lot of modifications. See, what, how is this showing? Yeah, see, for the same code, there are 2 different outputs. VS Code like really would really make me go mad. Okay, so all this is 6. So as Mona said, if we don't have a break and one of the conditions gets executed, then all the conditions after that that don't have a break will also get executed. How this works is like I'll tell you. I'll give you an analogy. Okay, so suppose a man in t equals to 1, let's say it's a man. Okay, so it's standing at case 1. I mean at the topmost floor. Just imagine that case 1 is the topmost floor of a building. Okay, and okay, what will happen? Nothing will happen actually, because like there is nothing after the break, so nothing will happen. If we had a default, then that would have been a different story. Okay, so but later, right now, if the analogy is clear, then you can like say yes, what is happening. So see, so this a is equals to 1, and this same output even if we remove 3 x. Yeah. So suppose this a equals to 1 is a man, and since case 1 satisfies with a, so right now a is standing at 1. Okay. Now this man decides to jump from the topmost floor, not towards outside of the building, inside of the building. Suppose floor 1 has a hole in it. I mean, case 1 is a topmost floor and it has a hole uh, in the middle of the floor. So he jumps from there. So what you originally expect is that you jump from the topmost floor and you land on the second topmost floor, right? So, but if you remove the break, that is, if you even remove the floor of the second topmost floor, so then there is another hole, right? So you keep falling, keep falling, keep falling until you find a floor that is intact. So this A was at case A. Now it cannot stop. It just has to fall, fall, fall because there is no break. Nothing to break is fall. So this type of a thing is called a fall through. That's why I gave this analogy. So is it clear, or do I need to like explain it once more? The analogy or anything if you want. In the meantime, I'll just write a default. Okay, any questions you can ask? Okay, so as I said, no breaks. I mean, there is nothing to cut the fall short. So it just keeps falling until it finds the base ground, that is the end of the switch case, and all the things are executed like that. So always remember to give a break. If you're not doing nested conditions, that's a even more different story. I will probably cover that in the next class. I mean, just don't do things like that. If you want nested stuff, then do if, or the program will be like really jumbled and you would be having problems understanding. So basically what I mean by nested is like you want something to get executed if the case is 1 or 2. So you mix them up together. So if the case is 1, then also this executes. If the case is 2, then also this executes, and then it breaks. Okay, so it cannot be like 1 and 2 together. So case 2 would say like you want to print the number if it's 1 or 2. So you print it out like this. But this is bad practice, so I don't recommend doing this. You know. So fine. Uh, what else? Okay. There is a thing called continue. So that comes when we go into loops. And just I'm saying that continue does not work in switch cases. Why? Just we are going to cover loops right now. So I'll tell you. Okay. So any questions till now? That was switch cases. So there are 3 things in a switch case. One is the expression that is evaluated, the number of cases, each representing a value, and the default case, which evaluates only when all the cases are false, and the break statement to like if one statement is executed, then break and go back. Okay, so we did not give a formal definition of break. I just gave you an analogy for break. So what happens with break is you'll understand it even more better when you do loops. So is there any questions till now till switch? And as I said, switch case can only be used on integer and character data types. So if we had a char a and a 1 proper stuff, let's just give a break. And then we had to give all this cases as 2, 6, all that. And then if we run, then this is 6. The first is just don't get confused which is getting executed. So this is 6. Evaluates the value, checks the value, prints does the conditions that are within that case. Okay. So any questions? No one is saying no or no one is saying yes. So I have been like asking this question. Is there any question for like 4 or 5 times? So if there is not, I'll just write the definition and move ahead. Okay, so that brings us to the end of if else and switch cases also. That is basically a decision making. And we have day 5. Oops. So, as I said, we'll be going to cover loops today. Okay, guys, can you hear me? Like, am I audible yet? Still, somebody message me like, can't hear me. Okay, yeah, fine. Okay, so I was not telling anything, Pawan. I was just typing. Yeah. So basically, I wrote the definition of switch, which I don't need. You need to. I need to explain it again. So because I already said it so many times. Okay, so we'll go into loops. Okay, so why do we need loops and what are loops first of all? So suppose a programmer is very lazy, okay, and we live in a world where whatever we want to write, we need to write it with programs. So you remember those punishments that teachers used to give us, like write this 100 times, that I'll not do this again and all that. Okay, so suppose we live in a world where pen and paper don't exist. So a teacher has given a student a task that you have to write. I will not do this again 100 times on in C++. Okay. So now he's very lazy. Probably that's why he got the punishment. So he has to now write C out. I will not do this again a 100 times. Imagine writing this 100 times, and imagine copy pasting doesn't work. Okay. So there is no function of copy pasting in that world. So he has no choice other than to write C out. I'll not do this again. I'll not do this again 100 times. Okay. And after that, all the fingers will be sore. Okay. So now to save his life comes a concept in programming that is looping. So when you want to, so what does loops mean in general? So when you hear the term loop, we think like a circle, and a circle you'd see that the if you go from the start point to the end point, that is the same. So we start from where we start. If we want to trace the circle, we come to this back to the same point. So that is the concept of loops. A same thing is repeated time after time after time after time. So no matter which point you choose to start, if you trace the circle, you would come back to the same point. Okay, so that's how loops work. So first I'll be categorizing how many loops are there, what types of loops. Then we'll write this 5 times. I'll not do this again. Or a cooler statement, not this. Okay, so types of loops. So loops are, there are like two types of classification of loops. This first type everybody kind of knows. I mean, those who have done a bit of programming before. Exit control loop. Oh, VS Code is suggesting me loop even after I've typed loop. Nice. Okay. So entry control loops are like two types: for loops, while loops. Okay. There is only one type of exit control loops, that is do while loops. And there is another classification. So this I'll say like classification 1, and this will be like classification. So the first is, okay, counter controlled loop. So even if you know programming, I think this term uh, you might not have heard. Even if you have done C++, Python, Java, a lot of teachers don't actually say this. Okay, so Sentinel loop can be done using all the loops, and counter control loop can be done with all the loops. So how is it a counter control loop, or how is it a Sentinel control loop? We understand that by checking the syntax and not like only the for or the while or the do part. Okay, so okay, loops definition. Okay, bunch is a bit informal. Okay, so you can repeat the instructions for an unlimited time number of times, or for a limited number of times as well. So how, we'll see that. So first we have for loop, and the classification is done. We'll start with for loops. No, I first write the syntax, then go into the definition. So syntax is for. I'll not write this. I'll write this as a change. Most people, wherever you see, you'll see this as an increment or decrement, but its increment means +1 and decrement means -1 in computer terms. So it does not necessarily need to be minus or plus. You can like increase it by 5, divide it by 2, do whatever you want. So I'll write it as change. Okay, that's more appropriate. And we'll see a working if loop. First part is, as I said, this needs to be a initialization. Okay, so we initialize something. So we initialized int I equals to 0, and next will be a condition. Okay, so we give a condition int I less than 5, and next is a change. So we change it by plus plus, which is equals to I plus equals to 1. Okay, so wait, open the scope. Okay, only printed in a line because I did not give the handle. Yeah, see, 1, 2, 3, 4, 5. So we initialized I as 0. We are checking I less than 5 and I plus plus. So these are the three parts of for loop, and we have written all the three parts. Now how this works. So I is initialized as 0. Fine. until this condition is not satisfied, this loop keeps running. So until I does not become 6, this loop keeps running. So first I is 0, it checks the condition, which is I less than 5. So it's true, obviously 0 is less than 5. Yeah, I'll say all that, don't worry. We can initialize beforehand, we can initialize it in loop, whatever. We can skip the initialization as well. That also doesn't matter. So we can do a lot of stuff. So wait, first from the basics, then to the advanced. So okay, as I was saying, so I is this condition is checked. I is less than 5. Obviously, I is less than 5 because it's 0. 0 is less than 5. And then we go into the loop. We don't do the plus plus right now. The plus plus is done only after the first it is executed, and then it comes back. So that's why we write a plus plus, right? Because plus plus is uh, do things then change. Okay, so this is I. Okay, did I cover plus plus? So you guys know what a plus plus is. So I plus plus is equals to I plus 1, but this is uh, first keep the variable there and change it after that. So if we do a equals to I plus plus, then and I is equals to 0, then a will be evaluated as 0 and the storage of the value would be 1, but a would be 0. Okay, so that's the thing. The plus plus is first execute then change, and that is the post plus plus, that is this. And the pre plus plus is the pre increment operator is first change then execute. So basically is like we do plus plus, but first we execute. So I value is currently stored as say 0, only 0, as only 0 only. What I mean is I value is stored as 0 only. We get into the loop, and after that we'll see what happens. Okay, so condition is checked. I plus plus is done, but plus plus says that first do the execution, then do the change. So we come back, we print this. Okay, so this is the first print, and then we go back here. Now it again checks for the value, that is I less than 5 or not. So i's value is currently 1. So 1 is less than 5, goes into inside it again, does another print, again a plus plus, that means plus plus happened, so that means its value is now 2. 2 is less than 5, prints it again. 3 prints it again, and for 4 it prints. Now see, now plus plus happens, i's value becomes 5. It checks the condition, that is I less than 5 or not, which is not, because 5 is not less than 5. So it comes out of the loop. It will not execute the loop anymore. Okay, so that's why it prints 5. I will do this again. So any questions with loops? So basically it will run till 0 to 5, 0 to 4 for all I values, 0 to 4. So any questions? Anyone else? Like you might ask anything like what would happen if we do plus plus there and there. Okay. So now coming to Doyle's question, that can we initialize it outside? Okay, can. And then after that also, yeah, we can. Okay, Rohan's no is for the previous one. Okay, clear. Is there latency? Like I'm saying now when the answers are coming after a long time. I noticed there's 2 times, like people's answers are coming a lot after. I don't know why. Okay. So anyways, so 12th question was, is it mandatory to initialize within the loop? Can't we do beforehand? Okay, yeah, we can. My answer is that yes, we can do it beforehand, and then also we can like initialize it. We can change the definition again, like I0, we can do it I1 here as well, and we can do I0 as well. So it doesn't matter. We can do it again, but if you have not previously declared this I, there is a difference between declaration and initialization. Initialization is when we assign a value, and declaration is when we tell the compiler its data type. And this type of statement is like we are doing declaration and initialization both at the same time. So if it's not declared previously, that is, if you have not said what is I, then if you do this, it's wrong. If you even skip the initialization, then also it's wrong because there is I and the compiler does not know what is I. So if you do this as 0, then also it does not work because I is not declared previously. So you, why we do this is because we want to declare it for, because there are many number of for loops. You can have many number of for loops in your program, and then you have to go back and declare that many values of I, j, k, whatever you want. So that becomes a bit complicated. So we generally initialize it in here, but a good programming practice is always initialize the value beforehand, and then uh, whatever you want to set it in the loop, set it there, and then run the loop. Okay, so if I do this as 1, then can you tell me how many I will do this again will be printed? We'll probably not finish loops today, and I'll like extend the class for like 5 minutes or so. But that's not the point. The point is like if we do it as 1, then can we print this? I mean, how many times will this be printed? Any idea? 4 times. Yeah, Sanjukta, that's fine. For anyone else? Okay, 4, 12, fine. Okay, guess 4. 4. Everyone says 4. And yeah, that's 4. Because we are going from 1 to less than 5, that is 4. Uh, I mean, we are going to 1, 2, 3, 4. The moment is it becomes 5, the loop stops. So 1, 2, 4, including 1 is 4 times. So we can print this as we can print this 4 times. Okay. So now, as I said, we can skip the declaration as well, but then we cannot like keep this as I anymore because I is not declared here, and we have to skip this as well. We can give any other conditions, say true, false, 5 less than 6, that, and even that is not necessary because if you don't give the condition, it's automatically assumed as true, and there is no change, there is no declaration, nothing. So in this type of a case where there is nothing, the condition, see, the condition is mandatory, you have to give. If you don't give it, the compiler will assume it as true, but a loop cannot run without a condition. So the condition would always be like assumed as true if you don't give anything, and if you specify it, then that will be the condition. So if I run this now, you'll see a very terrible thing. See, this is what is called an infinite loop. You might not understand this, but this is keeping happening. Like I will do this again, I'll do this again. This is like a lot of times it has printed. So if I go back, you see this many number of times it is printed, and whatever previously was on the console has been erased. So this is what we call an infinite loop. Okay, so don't do this. Like this is just for information, but like there is no point of using an infinite loop. There is point of using a delay loop in some programs, but no point in using an infinite loop. Yeah. Okay, probably a miss mic touch. Okay, so there is no point of using an infinite loop because your program will just keep running like that. Uh, there is an use of infinite loop, but that is something else. So if you code some, say what, microprocessors, you'd always see that you do all the instructions in an infinite loop because a device needs to always check if it's working or not. So as long as it's on, it will use those instructions. So yeah, there is use of infinite loop, but not in programs that you will face. If you program a microprocessor and all that, like what is that? Arduino, if you program an Arduino or something, then that might be used, the infinite loops. Okay, so that was that for loop. So any questions? Yeah, that is the most important part. If you have any questions, you might have, you might not. But if you have, then please ask. Okay, Roham has no question. Anyone else has any question? Mm, no, yes. Like there are so many people in the class. So I expect, okay, if you don't have any questions, then that's fine. We can move ahead. We'll like write the definition. So okay, so whatever variable you are using in the for loop, that variable is called the control variable of that loop. Okay. Not only for loop, for any loop, that variable is called the control variable. So the loop is controlled by that variable. So in our example, it was I. Okay. And when we don't have anything, simply the loop becomes uncontrolled, like we saw, and an infinite loop occurs. Okay. That's the thing. Okay. And also another thing, as I said, only the condition part is necessary. You can skip this other two parts as well. So let's say if you already defined I equals to 0, and now you don't want to define all this, but you still want your loop to run from 0 to 4, then you can do the change part inside the loop. That is also absolutely valid, and this will also run 5 times only. Okay. If you have any questions, type that regarding that, or I'll just write the definition and move ahead. Okay, the initialization condition and the change. Okay, so we are done with for loops for now, and have while loops. So as I said, for loops and while loops are entry controlled. So the entry control part means is that before entering the loop, the condition is checked, and then we get inside the loop. So here also, like every time we come back to this, we check it if the condition satisfies or not, then we enter. But there is also an exit control loop where we first execute the statements at least one time. Then we check if the condition satisfies. If the condition satisfies, the loop runs again. If the condition is not satisfied, then we just exit the code. Okay. And there is also counter control and sentinel control, but don't think we can cover it. I mean, whatever you're saying, seeing all these are counter controlled, and I've not given an example of sentinel control yet. So while loops. Okay, did I write the syntax? Okay, today I'll write the whole thing, conditional statement, and not only statement or condition. Okay, so this. So the while loop is like not so sophisticated as for. It does not like really want so many things like a initialization, a change, a, but it just requires a condition. So the for loop won't like ask you for even the for loop just shows to be sophisticated, but it's not. Inside it, it still just requires a condition. And if you don't give it a condition, then it's assumed as true. But here in case, you cannot write a for loop without giving a condition. You have to give it condition or a statement. A statement, if it's like while a, then you know the statement, single variable statement is false only when it's a 0, and for all other values it's true. Okay, so here we give something like I equals to 5, and we print from while. So now tell me, like, what do you think would be the output? Any ideas? See, we are not doing any. We are doing the initialization outside because you cannot do it inside while loop. So we are just giving a condition I less than 5, and then we are doing a simple instruction that is cout from while. We are printing this, and there is no change, nothing. So what do you think will be the output of this small snippet of code? Okay, Monal says nothing. And anyone else? Nothing. Okay. Okay. Oh, sorry. Did I give I greater than 5? Yeah, for that it was right. Now tell me for I less than 5. My bad. I actually wanted to give I less than 5. So now what happens? Yeah, nothing will happen because 0 is not greater than 5, so the loop won't run. Okay, from while. Uh, Only one time, or like 4 times, or 5 times, or 6 times, or what? Like from while, from what you have from while printed only one time. Okay. Okay, interesting. 5 times. Some says 5 times. Okay. Fine. Nice. Okay, from while one time. Okay. Nice. So I'll run this. See. Nice way to give the feedback form. Yeah, so it's an infinite. So see, like you are not doing the change anywhere. I is always 0. There is no change of I plus plus. This is like typing that for, and we have a true inside this, and then we are printing that, like we are doing printing that C out. I will do this again. So uh, this is just like that. We only have a condition which is always going to be true if you are not going to change the value. So I is 0. After this loop is executed one time, it still is 0, right? The I is not changed at all. So like that, you keep executing this, but I does not change. The condition is always going to be true. In no case, 0 cannot be greater than 5 if you don't change it by 1, 2 or something. So this is an infinite loop. So what we do to counter this is we do the change inside the while loop. So after all the instructions are carried out, we do the change here. So Kajal, you shared the feedback from this fine, but I will continue for till 6:45. You know, like yeah, that was like a weird mistake for people who are learning Python. So this was not that tough. Okay, so now all the loops we saw right now counts something. Okay, we do like uh, if we do our I plus plus. So you can continue. Yeah, okay, fine. So we'll just go to 6:45 and just go to Sentinel control. I'll give you a basic definition of Sentinel and counter control. Okay, so if we do this I plus plus, then we are changing the value. Fine. So it's supposed to run till 0 to 4. That is till it is less than 5. So it runs a number of times. But what if you want to run a program that is not dependent on the number of times? It can run any number of times until a condition satisfies. So we cannot do that with while loop we just saw, because we're not changing it. So we have to change it somehow, uh, but not by incrementing it. Then you are running it a number of times. So what we do is we take, what if we do something like this? And oh, sorry, this will be a cout. And okay, so this is a, did I? So this is a code now. So the condition is I less than 5. Each time we ask for a number and we get it in from the user. So this program can run any number of times when we run, until and unless the user is giving a value that is greater than 5 or equals to 5, the program will run. So let's just try it out. I'll not give many numbers, don't worry. Okay, I missed the colon with the numbers. Sorry. Okay, I give, see, okay, this is a bit confusing. So we'll give the colon and we'll type this again. Okay, score wise so slow. 2, 3, 34. See, we gave 34, the program stopped because 34 is not less than 5, and the program hence gets out of the loop and stops. The program stops, it comes to the end, and the program stops. So this type of loops can run any number of times dependent on the input that is given. And if, here we're not changing it by an I++ or an I plus equals to 2. So you cannot count the number of times the loop will run just by seeing the code. So this type of loops are called Sentinel control loops. I'll write the definition between Sentinel and counter next class because we have a bit of less time. So just give me 2-3 more minutes. Okay. So is this understood till now? So why is, okay, I'll just explain why this is called a sentinel control loop. So a sentinel means a guard. So here, imagine that this file has a guard. So it checks that if you're less than, only less than, suppose it's a kids party. So there's a guard there and he's standing. So here he's checking everyone's age, that if you're less than 5, then only you can get in. If you're not less than 5, then you cannot get in. So the loop runs till there is like any person who is greater than, who is not greater than 5 or equals to 5 has come to the guard. If that happens, then the loop stops. So the party stops. So some elder has come and now you have to stop the party. So the kids party is over. Okay. So that's the thing. Is my analogy clear and is this understood? So this is called a sentinel control loop and why I tried to explain. So is this clear? And we'll end this class here only if this is clear. And we'll leave do while. We'll go into that exit control loops. We'll go to do while next class. Counter and sentinel is clear. Counter like runs for a number of steps, which can be determined by seeing the syntax. And no. The feedback form is not a medium of for attendance. So like don't have to give unnecessary positive or negative feedback just because you have to get the attendance. So you don't have to do that. Only give feedback if you have to say something. Most probably negative because positive feedback is fine. It does not do much. So like even it's not only the feedback form. If you just give me the feedback in the class also, that is also fine. So I can understand where I have to improve or not. See, we are like coming to the end. We have only 3 classes left, and after that, CODE INIT part 1 will be over. So, yeah, if you have no questions, that comes, I mean, that brings us to the end of the class. Okay, 5-star rating then. Thank you, but you did not have to. So, yeah, but thanks still because you did. I hope you understood. That's why you give 5-star, not because you have to give 5 stars. Okay, I hope that's clear because I always say if you give a negative feedback, that's also fine. And you can give it in front of my face also. You don't have to hide under anonymity and write things. You just say that you're speaking fast and I can't understand. So you have to repeat this. So that I will do, no problem. Yeah, so that's it. If you have any questions regarding anything we understood right now or in the previous class also, if else any part, I can go through that. Otherwise, you can leave. I'll just stay here till 6:50. So if you have any questions, ask till that, or else you can leave.